this video, we are going to analyze and model a regression model to using this data set. Actually, this data set is coming from gem auction data, some sample data set from the gem auction, about 50 gems, and these parameters are these variables are recorded in the data set. Price is taken as the response variables, while other four variables are taken as the predictor variables, and gender is an indicator variable. Let's see. First, we have to see the two-way relationship. So we go to scatterplot option under the graph tab, and we can draw scatterplots one by one like this. So then I have selected 5 fields under X and Y. So first graph is price and age, price and size, price and attendance, age and size, age and attendance. And here we have only 4 variables which have numerical data or quantitative data. So we can draw scatter plots for those kind of variables. So I can select the rest using. Now we have age and size, age and attendance. So I may select size and attendance, and you can click OK. Since we did feed data to this scatterplot option, we can have separate scatterplots like this in our space. So here we can see there's a linear relationship. So we can expect a linear relationship between price and age. And here the price and size, they are also a visible linear relationship. And the price versus the attendance, there are also some kind of linear relationship is visible. And age and size, here also data are scattered, but we can expect linear relationship, so as here. So we can append those graphs to our report by selecting this topic and right clicking on it. So then we can append that graph to the report in the Minitab workspace or any other Microsoft Word or PowerPoint document where we have open in our working space. So then under the graph option, we can draw all the graphs in the same. So since gender is a categorical variable, so I may use with groups option, because then I can see the relationship of them at once. So my graphing variables are price, age, size and attendance. My categorical variable is gender. So by clicking at once, all the graphs are displayed in one plot. So here you can see black dots represents females and red squares represents males. So those individual graphs, scatter plots, are systematically listed in this. So this is age price graph and age size graph, size and price graph. So you can refer only one triangle, which means the upper triangle or the lower triangle of this matrix. So at the same time, you can get an idea about how gender is distributed around here. So here you can see females in the lower part of this graph, or the left hand side of this graph, while the males are on the right hand side of this graph. But in here you can see females in the middle part, while the range of females are very is very small, and these red dots have a wider range. Likewise, you can interpret those things. So after seeing it, you have to go uh, to the correlation matrix, which means you have to do the correlation test to identify the significant relationships. So there you have to go to stat tab, and under the basic statistics you can find correlation. So in the correlation you have to select price, age, size and attendance, then display p-values. You by default it is ticked. You can store this matrix in another place without seeing the output if you want that one. So you can assign tick this box. So I need to see it. So now my output is this correlation of price and age is significant since the p-value is less than 0.05, which means at 5% level of significance, these other than this, which means the correlation between size and attendance is insignificant, while all other correlations are significant at 5% level of significance. And you can see uh, price is highly correlated with age and size. So while age and size, you can see it also, both those two variables also highly correlated. So we can expect a multi-correlated effect in the model, but we can test that in the model building procedure. Now we can see what are the suitable variables for to model that case. So we can see we can use both age and size, and since there is significant relationship, linear relationship, but it is poor, weak and positive, but we can use attendance to the model as well. So then I'm going to build a regression model. So you can take this scatter plots, matrix plot, or and this correlation matrix to a report. Then we go to the stat tab, and under the regression we have two options: regression and general regression. First, I am going to build a model without gender. So I am giving the response variable as price, and the predictors are age, size and attendance. Once you select response and predictors, you have to go to graphs. So there we use residual plots of regular residuals, and for the residual plots I select 4 in 1 plot because I know the order. If I know the order of these data observations, if you don't know the order, you have to go to individual plots and tick these 3, because residual versus order graph cannot be taken since we don't know the order. But here we know the order, so we can ask for a 4 in 1 plot. And if you want more residual plots with other predictors, residual versus other variable predictors, age, size and attendance, you can select those predictors in this box and ask it to print. And under the options, you can see if you want to add weights for some variables, you can add that here by uh, inserting those weights in a separate column. And if you don't want the intercept of the model, which means beta node, so then you can untick this one, and you have to tick this various inflation factor to check the multicollinearity, because if the VIF value is greater than 5, the data set shows high multicollinearity effect. And if you want to do the lack of fit test, you have to select these things, and Durbin-Watson is used to find the autocorrelation of residuals. Likewise, you can do these things, and if you want to predict uh, data using the model, you have to add those data points in here if you have a single new observation. But if you have set of new observations, you have to include those observations in separate columns and feed those column numbers or column names in here. Suppose I need to input a new observation uh, to the building model. So I am using a new observation related to the age 150 and size of the attendance is 100 and the experience of the buyer is 8. Now I after building the model, I need to substitute these three values in my model and get the prediction band and the confidence band for the mean response of the new observation. So I want this confidence limits and prediction limits, and also I need to know about the fit or the prediction value of the model after substituting these 3 points in the model that we are going to build. So I'm taking fits as well. Now here under this result, by default I need these results, so I'm not going to change those things. On the storage you can have additional matrices and residuals if you need to use those things for another calculation. If you need that, you can take these things. Now okay, now you can see the residual versus attendance. So here also we can see a band or distribution is on a band, and here also we can see the residuals are distributed in a approximate band. Here also we can see that band. And in the normal probability plot, we can see the residuals are normally distributed, and here residuals as a fitted value plot, so it is band. So residuals are normally distributed, and here variance is constant, and here we can see it is randomly, which means residuals are independent now. So we can go to the model interpretation. So this is the model. So this is the model that we built here. These are the test results for the significance of each parameter. So this is the beta naught value, and this is the p value for the hypothesis test, where h naught is equal to beta naught equals 0. Hypothesis, this is beta 1 value, beta 1, beta 2 and beta 3. These are all hats or estimates, and we test whether these parameters are equal to 0 or not using this p value. So this p value is related to that hypothesis test. So according to here, the results, you can see beta 3 or the parameter of attendance is not significant, since this p value is greater than 0.05, which means at 5% level of significance, beta 3 is insignificant, which means attendance doesn't influence the price. So, and you can see under the VIF value, age and size are causes to causing the multicollinearity effect, since VIF value is greater than 5. So one thing we can do is we can use either age or size to predict or model, to build a model with price. That's the one solution. So we can go to the significance of the model first. Then here p value is 0, which means beta 1, beta 2, beta 3 equals 0. Hypothesis is rejected, which means at least one beta is not equal to 0. So this is the first table that you have to refer in your output. So once you refer this, if the model is significant, so then you can go to this coefficient table and you can get beta hats in here. Under the coefficient column you have beta hats, and under the p value, so you can see the significance of these parameters. So here it says not all betas are equal to 0, and here you can see beta naught, beta 1 and beta 2 are not equal to 0, but beta 3 is equal to 0. And then one thing you can say is you can drop this variable and fit the model again, or you can drop either age or size and fit the model again to improve the model. But I'm using this model to do my rest of the calculation. So now, since this is a multiple linear regression model, so I'm interpreting the R square adjusted value. So it is 91%, which means 91% of the variation of price is covered by age, size, and attendance. So then I am coming to this predicted values uh, for new observations. So here fitted value is 24,314 and its standard error is 360. So this is the confidence interval for the mean response of the new observation, and this is the prediction interval of the new observation. And here you can see this is the new observation. So these results are printed on the worksheet as well. So you can see this is the fitted value, this is the confidence interval for the mean response of the new observation, and this is the prediction interval for the new observation. So that is how we can run a complete um, regression analysis to a data set without a indicator variable and without interaction terms. But if we need to build a model with interaction terms and adding indicator variables to the model, which means qualitative variables are uh, transformed to indicator variables to add them to the model, so then we need to use the other option. There I am going to stat again. Under the regression, I have general regression. So select general regression. So my response is price. Model is age, size, and attendance, which means I need the main effects of age, size, and attendance, and I need to take the interaction effect of age and size to the model. So age star asterisk size. So this term denotes the interaction effect of age and size. So I need to include that thing to my model as well, and I need to inside here include the gender to the model as well. Once you insert a categorical predictor to the model, you have to mention that categorical predictor tag in here. So I'm using Minitab 16 version. So on the 16 version, you have this general regression approach, but in the previous version, older versions, you have general linear model option in your software. So now we have selected all the necessary variables, and here you can see we need this intercept, and we are using this two-tailed confidence interval. So no, we are using this default options to here, but typing the coding of the category predictor is 0 and 1. You have to select that thing, and you have to give the reference level to here. So it is 1, which means male. So suppose you used male and female text in this column, so then you have to select 1 and 0 and give male as the reference level in text format. Here I have used 0 and 1 already, so I'm giving 1 as the reference level. Now you can go to the graphs and ask for 4 in 1 again. Here also for prediction, if you need a prediction, new observation for the continuous predictors, I can give the previous new observation as this, and new observation for the categorical predictor, it is 1. Suppose this new observation denotes for a male who bought a 150 years old gem where 100 participants were in the auction, and his experience is 8 years, which means he has visited this auction 8 years. Then you have to select confidence limits, prediction limits, and fits according to your need. Then press OK. So here we see there's a problem in the last dialog box. So I'm going to the back to it. So here I think there's a problem with this the limits of the coding or the type of the coding. So it is one, and I'm removing one from here because I have used 0 and 1 already. So I don't need to give 1 as a reference level. Automatically 1 is the reference level. So you can use this option if you have used text as the levels of the variable. So now press OK and press OK. So this is the residual plot. So it's the same thing. If you can remember, uh, in the previous histogram we had some bars with equal height, but now somewhat bell-shaped graph is obtained, and here also we can see residuals are normally distributed since these dots are distributed on the line and around the line symmetrically, and here we can't see any pattern in this distribution. It is approximately distributed on a band, and here also we can't expect see a pattern, which means errors are normally distributed and they have a constant variance and they are randomly distributed. So our assumptions are okay. Then we can go to this output to the interpretation of the model. First we refer the ANOVA table. So in this ANOVA table, you can see the main effects are listed in these rows, and the interaction effect is here, and the gender is here, and this is the regression one. Since the regression is significant, we can see individual significance of these variables as well, and you can see age and size interaction is not significant or insignificant, which means we have to fit a model without interaction term in the next time to improve this model. And here also lack of fit test also done. So lack of fit is not in this data set because it is greater than 0.05. The null hypothesis is not rejected. So we can go to the model. Okay, so here ASPA adjusted is 90%, and we can say about 90% of the variation of price is the covered by age, size, and attendance main effects, as well as the age, size, interaction effect, and the gender variable. So, but in this model, in the coefficient table, you can see the constant is insignificant. So this p-value is related to the hypothesis test of beta not equal to 0. So here beta not equal to 0, which means you have to fit a model without the intercept to get a better improved model. And these values we saw in the ANOVA table as well. Here, to improve this model, we have some suggestions. One thing is you can eliminate the intercept, or one thing is you can eliminate this interaction term or attendance and fit the model again. And gender variable is also an insignificant variable, but before removing gender, it is good to remove interaction effect, because if the in the interaction terms, if the highest interaction is significant, so then it is okay to keep the lower interaction and main effects of variables, though they are insignificant. But if the highest interaction or highest order interaction is insignificant, then you have to remove that one and build the model again. And this is the model. So this is the model when the rest or the buyer is a female, and this is the model when a buyer is a male, because we denoted one as males and 0 as females. So if you can imagine, this is the mode of this variable. So I'm this you can, if you can see, this is beta 1, this beta 2 hat, and this is beta 3 hat, and this is beta 4 hat. So beta 5 hat is uh, related with this gender. So in here this is beta naught, but for males this is beta naught plus beta 5. So in the coefficient table you can see this is 40. So you can see 2885 plus 40 is this. So that is how you can use Minitab to build the regression model. I use this data set to show you how to build this regression model. It is a multiple linear regression model, and for this model also you can see the fitted values, and this is the confidence, the prediction interval, and this is the confidence interval, so the mean response, and this is the fitted value. Now we can use the same procedure that we discussed to any number of variables to model the regression process. And you can see, if you have one response and one predictor, you have to be simple linear regression. So you can use the same procedure and build that model. So this is how you can use Minitab to do a complete regression analysis.